Hey everyone, and welcome. Today we're going to dive into a pretty amazing journey, one that starts with a simple, generous act and, well, it ends with saving a life. We're going to pull back the curtain on what really happens to blood after you donate it.
I mean, think about it. You sit in the chair, the donation's over, you grab your juice and a cookie, and you head home. But for that little bag of blood, its journey is just getting started. And it's this incredible, high-tech adventure that most of us just never get to see.
And you know, the one thing, the guiding principle for this entire journey, from the second it leaves your arm to the moment it reaches a patient, is all about one word: safety. It's a whole system of checks and balances designed to protect everyone involved, the donor, and of course, the person who's going to receive it. It is the absolute backbone of our trust in the system. So where does this all begin? You might think it's in some fancy lab, but actually, it starts right there with you, the donor. The very first step is a really thorough health check that happens before a single drop of blood is even collected. It's basically a four-part process. First, you get registered and give your consent. Then comes the confidential questionnaire. You know the one, asking about your medical history, any recent travel. That helps flag any potential risks right away. After that, there's a quick physical to check your pulse, temperature, and your hemoglobin levels. And finally, a medical officer looks over everything to give the final green light. Every single step is another layer of protection. Okay, so once the blood is collected, it gets labeled and is whisked away to the lab. This is where the donation really gets its identity. Let's dig into how they build that unique profile for every single donation. So how do they even know your blood type? Well, it all comes down to something called antigens. The easiest way to think about them is like little flags on the surface of your red blood cells. And depending on which flags you have, the lab knows if you're type A, B, AB, or O. But here's the thing. They don't just check once. To be absolutely 100% sure, the labs run two completely different tests. The first one looks at the red blood cells themselves to see which of those flags, the antigens, are there. The second test looks at the liquid part of your blood, the serum, to see which antibodies are floating around. If both tests give the same results, bam, they know they've got it right. It's a fantastic double-checking system. And of course, there's the whole positive or negative thing, right? That's the Rh factor. It's just another one of those antigen flags, but knowing if it's there or not is so important. A mismatch with the Rh factor can cause a really dangerous reaction, and it's especially critical for pregnant women to make sure both mom and baby stay healthy. All right, blood type is confirmed. Now, the sample moves on to the most intense part of its journey. Think of it like a microscopic safety scan, looking for any hidden dangers. Now, this is non-negotiable. Every single unit of donated blood is screened for a mandatory list of transfusion-transmitted infections. We're talking about HIV, Hepatitis B and C, Syphilis, and Malaria. This screening is an absolute cornerstone of keeping the blood supply safe. And the technology they use here is, well, it's seriously impressive. There are two main methods. The first is called ELISA, and it looks for the body's response to a virus, the antibodies it creates. But the second, more advanced method is called NAT. That's nucleic acid testing. Instead of looking for the response, it looks directly for the virus's own genetic material. This is a total game changer because NAT can spot an infection way, way earlier, making our blood supply safer than it has ever been. So what happens if a test does come back positive? The answer is simple. It's absolute. That unit of blood is immediately and safely discarded. As the source material puts it perfectly, it doesn't go anywhere near a patient, period. The donor is then notified privately and offered counseling and care. Safety first, always. So, once a donation has passed every single one of those tests with flying colors, it's officially cleared for use. But hang on, it's not quite ready yet. The final stage is all about prepping it for its specific life-saving mission. And here's a really cool part. A single donation can actually end up helping multiple people. How's that possible? Well, the whole blood is put into a centrifuge, which is a machine that spins it at super high speeds. This separates it out into its core parts: red blood cells, platelets, and plasma. That way, doctors can give a patient just the specific component they need. And each of these components is a bit of a diva. They all need to be stored under very specific conditions. Red cells, they have to be kept refrigerated to stay in good shape. Platelets are kept at room temperature, but they have to be on these little machines that gently rock them back and forth so they don't clump together. And plasma, that gets frozen solid at -18 Celsius or even colder. It's this level of scientific precision that keeps every part safe and ready to go.
When you think about it, from the donor's chair all the way to a patient's bedside, this whole meticulous process does two things. Yeah, it saves a life right then and there, but it also does something bigger. It builds and maintains our trust in the safety and reliability of the whole healthcare system. So the next time you think about giving blood, remember this incredible, invisible journey. It's a story of science, of safety, and ultimately of human generosity. The journey is complete, and it all circles back to that one single act of kindness, magnified by science into a life-saving gift. Really, the only question left is, could one donation, just 1 hour of your time, be your legacy?